what's the difference between a state-of-the-art human, such as you and I? Well, I don't know if we qualify as state-of-the-art humans, but a state-of-the-art human and a state-of-the-art robot.
It's a very interesting question. Robot capability it's kind of I think it's a very tricky thing to understand, because there are some things that are difficult that we wouldn't think are difficult, and some things that are easy that we wouldn't think are easy. And there's also a really big gap between capabilities of robots in terms of hardware and their physical capability, and capabilities of robots in terms of what they can do autonomously. There is a little video that I think robotics researchers really like to show, especially robotics learning researchers like myself, from 2004 from Stanford, which demonstrates a prototype robot called the PR1. And the PR1 was a robot that was designed as a home assistance robot. And there's this beautiful video showing the PR1 tidying up a living room, putting away toys, and at the end bringing a beer to the person sitting on the couch, which looks really amazing. And then the punchline is that this robot is entirely controlled by a person.
Yes.
So in some ways, the gap between a state-of-the-art human and a state-of-the-art robot, if the robot has a human brain, is actually not that large. Now, obviously, like, human bodies are sophisticated and very robust and resilient in many ways. But on the whole, if we're willing to like spend a bit of money and do a bit of engineering, we can kind of close the hardware gap almost. But the intelligence gap, that one is very wide.
And when you say hardware, you're referring to the physical, sort of the actuators, the actual body of the robot, as opposed to the hardware on which the cognition, the hardware of the nervous system.
Yes, exactly. I'm referring to the body rather than the mind.
So
that means that the work is cut out for us. Like, while we can still make the body better, we kind of know that the big bottleneck right now is really the mind.
And how big is that gap? How big is the difference in your sense of ability to learn, ability to reason, ability to perceive the world between humans and our best robots?
The gap is very large, and the gap becomes larger the more unexpected events can happen in the world. So essentially, the spectrum along which you can measure the size of that gap is the spectrum of how open the world is. If you control everything in the world very tightly, if you put the robot in like a factory and you tell it where everything is and you rigidly program its motion, then it can do things, one might even say, in a superhuman way. It can move faster, it's stronger, it can lift up a car and things like that. But as soon as anything starts to vary in the environment, now it'll trip up. And if many, many things vary, like they would, like in your kitchen, for example, then things are pretty much like wide open.
Now, again, we're going to stick a bit on the philosophical questions, but how much on the human side of the cognitive abilities, in your sense, is nature versus nurture? So how much of it is a product of evolution, and how much of it is something we learn from sort of scratch, from the day we're born?
I'm going to read into your question as asking about the implications of this for AI.
Of course, exactly.
I'm not a biologist. I can't really speak authoritatively about that topic.
So, and to linger on it, if it's all about learning, then there's more hope for AI.
Yeah. So the way that I look at this is that, first, of course, biology is very messy. And if you ask the question, how does a person do something, or how does a person's mind do something, you can come up with a bunch of hypotheses, and oftentimes you can find support for many different, often conflicting hypotheses. One way that we can approach the question of what the implications of this for AI are is we can think about what's sufficient. So, maybe a person is from birth very, very good at some things, like, for example, recognizing faces. There's a very strong evolutionary pressure to do that. If you can recognize your mother's face, then you're more likely to survive, and therefore people are good at this. But we can also ask, like, what's the minimum sufficient thing?
Right.
And one of the ways that we can study the minimal sufficient thing is we could, for example, see what people do in unusual situations. If you present them with things that evolution couldn't have prepared them for. Our daily lives actually do this to us all the time. We didn't evolve to deal with, automobiles and space flight and whatever. So there are all these situations that we can find ourselves in, and we do very well there. Like, I can give you a joystick to control a robotic arm, which you've never used before, and you might be pretty bad for the first couple of seconds. But if I tell you, like, your life depends on using this robotic arm to, like, open this door, you'll probably manage it. even though you've never seen this device before, you've never used a joystick to control this, and you'll kind of muddle through it. And that's not your evolved natural ability. That's your flexibility, your adaptability. And that's exactly why our current robotic systems really kind of fall flat.
But I wonder how much general, almost what we think of as common sense, pre-trained models underneath all of that. So that ability to adapt to a joystick requires you to have a kind of, I'm human, so it's hard for me to introspect all the knowledge I have about the world. But it seems like there might be an iceberg underneath of the amount of knowledge we actually bring to the table. Yeah. That's kind of the open question.
I think there's absolutely an iceberg of knowledge that we bring to the table, but I think it's very likely that that iceberg of knowledge is actually built up over our lifetimes, because we have a lot of prior experience to draw on, and it kind of makes sense that the right way for us to optimize our efficiency, our evolutionary fitness, and so on, is to utilize all of that experience to build up the best iceberg we can get. And that's actually while that sounds an awful lot like what machine learning actually does, I think that for modern machine learning, it's actually a really big challenge to take this unstructured mass of experience and distill out something that looks like a common sense understanding of the world. And perhaps part of that it's not because something about machine learning itself is broken or hard, but because we've been a little too rigid in subscribing to a very supervised, very rigid notion of learning, kind of the input-output, X's go to Y's sort of model. And maybe what we really need to do is to view the world more as like a mass of experience that is not necessarily providing any rigid supervision, but sort of providing many, many instances of things that could be. And then you take that and you distill it into some sort of common sense understanding.
Let's see. Well, you're painting an optimistic, beautiful picture, especially from the robotics perspective, because that means we just need to invest and build better learning algorithms, figure out how we can get access to more and more data for those learning algorithms to extract signal from, and then accumulate that iceberg of knowledge. It's a beautiful picture. It's a hopeful one.
I think it's potentially a little bit more than just that. And this is where we perhaps reach the limits of our current understanding. But one thing that I think that the research community hasn't really resolved in a satisfactory way is how much it matters where that experience comes from. Like, do you just like download everything on the internet and cram it into essentially the 21st century analog of the giant language model and see what happens? Or does it actually matter whether your machine physically experiences the world, or in the sense that it actually attempts things, observes the outcome of its actions, and kind of augments its experience that way?
That it chooses which parts of the world it gets to interact with and observe and learn from.
Right. It may be that the world is so complex that simply obtaining a large mass of sort of IID samples of the world is a very difficult way to go. But if you are actually interacting with the world and essentially performing this sort of hard negative mining by attempting what you think might work, observing the sometimes happy and sometimes sad outcomes of that, and augmenting your understanding using that experience, and you're just doing this continually for many years, maybe that sort of data in some sense is actually much more favorable to obtaining a common sense understanding. One reason we might think that this is true is that what we associate with common sense or lack of common sense is often characterized by the ability to reason about kind of counterfactual questions. Like, right. If I were to, here this bottle of water is sitting on the table, everything is fine. If I were to knock it over, which I'm not going to do, but if I were to do that, what would happen? And I know that nothing good would happen from that. But if I have a bad understanding of the world, I might think that that's a good way for me to gain more utility. If I actually go about my daily life doing the things that my current understanding of the world suggests will give me high utility, in some ways I'll get exactly the right supervision to tell me not to do those bad things and to keep doing the good things.
So there's a spectrum between IID, random walk through the space of data, and then what we humans do. Well, I don't even know if we do it optimal, but there might be beyond. So this open question that you raised, where do you think intelligent systems that would be able to deal with this world fall? Can we do pretty well by reading all of Wikipedia, sort of randomly sampling it like language models do? Or do we have to be exceptionally selective and intelligent about which aspects of the world we interact with?
So I think this is first an open scientific problem, and I don't have like a clear answer, but I can speculate a little bit. And what I would speculate is that you don't need to be super, super careful. I think it's less about like being careful to avoid the useless stuff and more about making sure that you hit on the really important stuff. So perhaps it's okay if you spend part of your day just guided by your curiosity, visiting interesting regions of your state space. But it's important for you to every once in a while make sure that you really try out the solutions that your current model of the world suggests might be effective, and observe whether those solutions are working as you expect or not. And perhaps some of that is really essential to have kind of a perpetual improvement loop. Like this perpetual improvement loop is really like that's really the key that's going to potentially distinguish the best current methods from the best methods of tomorrow, in a sense.